In this chapter, we've talked about arithmetic sequences and series. Now we're talking about geometric sequences and series. So let me backtrack. Arithmetic sequences are basically sequences where you notice that we are constantly adding or subtracting the same number over and over again. A geometric sequence or series is one where we're constantly multiplying or dividing. And when we're dividing, we still want to think of it as multiplying. It's just that what we're multiplying by is a fraction. Okay? So that common number in a geometric sequence is called a common ratio. So in arithmetic sequences, we had a common difference. In geometric sequences, we have a common ratio. And just like in arithmetic sequences where we found the common difference by taking, for example, A2 minus A1, we would take A2 divided by A1 in order to find my common ratio. So in example 1, that's what we're doing. We take 11 over 4 in order to find our common ratio, and we get 2.75. The problem is also asking us for the next 3 terms. So in order to find 1, 2, 3, 4, a sub 4, I'm going to take that 30.25 and multiply it by my common difference, 2.75, and I get 7.5625. A sub 5 is going to be that number times my common ratio of 2.75. So that's 20.796875. And then finally, a sub 6 is this times 2.75. So that's 57.19140625. That's it. Part B, ooh, interesting. We have a variable involved. Well, same process applies. I'm going to find my common ratio by taking a sub 2 and dividing it by a sub 1. So that's negative 16r plus 32 divided by 64r minus 128. So it might be a good idea to factor these two things. So in my numerator, I can factor out that negative 16, and that'll be r minus 2. And in my denominator, I'll have 64 times, r minus 2. So my common difference actually doesn't have, or my common ratio, excuse me, actually doesn't have any variables in it at all. My common ratio is negative 16 over 64, which reduces to negative 1/4. So in order to find my next term, I'm going to multiply each of these pieces of my third term in order to find my fourth term. I'm going to multiply them by that negative 1/4. So a sub 4 is negative 1/4 times 4r is negative r, and then negative 1/4 times negative 8 is positive 2. A sub 5, I'm taking this and taking negative 1/4 of it, so I'll have positive r over 4 minus 1/2, and finally a sub 6 is this multiplied by negative 1/4, so I'll have negative r over 16 plus 1/8. And if you're looking at what I got there and you're kind of wondering, oh my gosh, how did you do that with all those fractions? Remember that when you're multiplying fractions, you're just multiplying straight across the top and straight across the bottom. Okay, so very much like the last lesson in arithmetic sequences, we have a kind of explicit formula that we can use for a geometric sequence and finding a term in that sequence. Once again, in order to do that, we have to find the common ratio. So my common ratio here is 25 over 2, And since you notice this term being expressed in decimal form, let's express that common ratio in decimal form. So 25 divided by 2 is 12.5. So that means my explicit formula is a sub n equals my a sub 1, which is 2, times 12.5 being raised to the n minus 1 power. That's our explicit formula. Our recursive formula is a sub n equals a sub n minus 1, because remember, a recursive formula defines its next term in terms of its previous term. So what am I doing to a previous term in order to get my current term? We're multiplying it by that common ratio. So it's a sub n minus 1 times 12.5. In example 3, now we're being asked to use this formula in order to find a particular term in a sequence. So here I'm asked for a sub 9, and this is my sequence. I need to figure out what my common ratio is. So my ratio is 14 over 4, which is 3.5. And since I'm trying to find a sub 9, I'm going to multiply a sub 1, which in this sequence is 4, times that common ratio of 3.5 being raised to the 9 minus 1 power. And now this is straight calculator. I'm taking that 3.5 and raising it to the 8th power and multiplying that times 4. And so the 9th term in that sequence is 90,075.01563. In this problem, they didn't give us a sub 1, but they did give us r. So let's figure out what a sub 1 is. So a sub 3 would equal a sub 1 times that negative 4 raised to the 3 minus 1, which is 2, power. And since I know that a sub 3 is 32, now I just have this formula that I'm solving for a sub 1. So negative 4 squared is 16, and when I divide 16 from both sides, a sub 1 is 2. And now I have everything I need in order to find a sub 12. So a sub 12 is going to equal 2 times that common ratio of negative 4 being raised to the 12 minus 1, or 11th, power. So I take negative 4 and raise it to the 11th power. Now make sure in your calculator that you're typing in the negative. If you're typing the negative into your calculator, make sure that you're putting that negative 4 in parentheses before raising it to the 11th power. Remember, sometimes you've got to be smarter than your calculator. And then when I multiply that by 2, a sub 12 is negative 8,388,608. In the last video, we used that formula to find arithmetic means between two terms of a sequence. We can do the same exact thinking in order to find geometric means. So in part 5a, I'm asked for the two means between these two terms. Well, in order to do that, I have to figure out what my r is. In order to figure out what my r is, I'm going to think of this in terms of, here's my sequence, negative 4, and then there's two terms between it and 13.5. So we're going to treat this as a sub 1 and this as 2, 3, a sub 4. So 13.5 equals negative 4 times my common ratio that I don't know yet, raised to the 4 minus 1, which is third, power. Okay, so in my calculator, in order to get the r to the third by itself, I'm dividing 13.5 by negative 4. And my r cubed is negative 3.375. And in order to figure out what my common ratio is, I have to take the cubic root of that. So taking the cubic root of that is negative 1.5. So I know my common ratio is negative 1.5. And so now all I have to do in order to figure out what these two terms are is take negative 4 and multiply it by my common ratio. So that's 6. And then if I multiply 6 times negative 1.5, I get this term, which is negative 9. If I wanted to make sure I didn't screw something up, I might take negative 9 times that common ratio and make sure I get 13.5, which I do. So those are our two geometric means between negative 4 and 13.5. Similar idea in this problem. I could think of this sequence as 10 and then 3 terms between it and 0.016. So I'm going to treat a sub 1 as 10, and this 0.016 is my 2, 3, 4, a sub 5. So I'm going to use that in order to find my common ratio. So a sub 5 equals a sub 1 times my common ratio, which I'm trying to figure out, to the n minus 1, which is fourth power. So r to the fourth equals 0.016 divided by 10, which is 0.0016, excuse me. And I'm taking the fourth root of that, and that is 0.2. So my common ratio is 0.2. So I take 10 times 0.2, and I get 2. Multiply 2 times 0.2, I get 0.4. Multiply 0.4 times 0.2, I get 0.08. And 0.08 times 0.2 will equal 0.016. In the last lesson, we saw that we have two formulas for how to find the sum of an arithmetic series. Similarly here, we have two formulas for how to find the sum of a geometric series. So in part 6a, I'm asked for the first 11 terms of this geometric series. So since I know what a sub 1 is, I know what my common ratio is, I know how many terms I'm adding, I'm going to use the first formula. So s sub 11 equals my a sub 1, which is 7, times 1 minus, I got to figure out what my common ratio is. So my common ratio is negative 24.5 divided by 7, and that's negative 3.5. So I have 1 minus negative 3.5 raised to the 11th power over 1 minus negative 3.5. And then from here, it's straight calculator. So negative, actually, let's type this in exactly the way we see it. 1 minus, parentheses, negative 3.5, close parentheses, raised to the 11th power, divided by, well, hopefully you don't have to use your calculator for this part. So I'm dividing by 4.5. and I'm multiplying that times 7, and I get 1,501,877.337. Part B, let's look at the information that we have. We know what a sub 1 is. We know what a sub n is. We know what our common ratio is, but we don't know how many actual terms there are. So, well, in this formula, I need to know how many terms there are. In this formula, I don't. So let's use this formula since I know what a sub 1 is, I know what a sub n is, and I know what my common ratio is. So S sub n is going to equal -8 minus 131,072 times -4 all over 1 minus that -4. So using our calculator, we have -8 minus 131,072 times -4 divided by 5, and that sum is 104,856. Once again, we're using sigma notation, and we're trying to find the summation of everything from the 16th term to the 31st term of this explicit formula. So it is valuable to notice that this number is being raised to the n-1 power. That makes this number the r. So I can figure out my first term of my summation. I can figure out the last term of my summation, and if we refer back to our formulas, when I know my first and last and I know my ratio, this is a good formula to use. Okay, so let's first identify what our a sub 16 is. So in our calculator, we're going to take 0.5 times 2 to the 15th. So 2 to the 15th times 0.5 is 16,384. And a sub 31, brace yourself, this is going to be a large number. We're taking half of 2 to the 30th power. So 2 to the 30th, and then divided by 2, because that's the same thing as multiplying by 0.5. Whew. 5, 3, 6, 8, 7, 0, 9, 1, 2. Okay, so this formula, once again, is a sub 1 minus our a sub n times our ratio. So 16384 minus 536870912 times that common ratio of 2 all over 1 minus that common ratio of 2. So hopefully you realize that you're just going to take this numerator and then change its sign. So 16384 minus 536870912 times 2. So our answer is 10737254440. That is such a massive number. That is 1,073,725,440. Whew, big number. Same exact thought process for this one. we can treat this as our a sub 1 and this is our a sub n, and we know what our common ratio is, it's 0.5, and then we can use the exact same formula after we find our a sub 4 to be 120 times 0.5 to the third power. So 0.5 to the third power times 120 is 15. And then a sub 11 is 120 times 0.5 to the 10th power. And that is 0.117185. And again, our formula tells us to take our a sub 1, which in this case is our a sub 4, so 15 minus 0.117185 times our common ratio of 0.5, and take all of that over 1 minus our common ratio, which is 0.5. So typing that into our calculator, we get 29.8828.125. Finally, this lesson addressed sums of infinite geometric series, and an infinite geometric series will only have a sum if that common ratio, the absolute value of it, is less than 1. So you're basically looking for a fraction value, whether it's positive or negative, that is less than 1. So in problem 8, part A, I see that my common ratio is -5/10, which is -1/2. And since I've already glanced at these problems and realized that there's a problem with at least one of the problems, I'm going to double check and make sure that this is a geometric series by comparing this ratio to the ratio of the next two terms. So I'm going to make sure that 2.5 over -5 equals the same thing, and it does. So since it does, it'll have an infinite sum. And we use this formula. So we know what our first term is, we know what our common ratio is, and we just type it into our calculator. Our sum is going to equal 10 over 1 minus -1/2. So that's 10 divided by, you can think of it as 1.5, and that is 6.6 repeating. In part B, I check the ratio from 15 to 20, and that reduces to 3/4. And just to be on the safe side, I check the ratio from 10 to 15, and that's 2/3, which means this is not a geometric series, which means this is not possible to find an infinite sum. Finally, in part C, since I noticed that my common ratio is 0.8, it is possible. My first term is this 120, so my sum is going to be 120 divided by 1 minus 0.8. So that's going to be 120 divided by 0.2, which is 600.